If you are genuinely going to Mars, you have to master in situ resource utilization. You have to learn how to live off the land. The moon base isn't just a campsite. It's a proving ground for a highly specific chemical process.
Which is mining the ice.
Mining the ice, melting it, and using electrolysis to split the H2O into hydrogen and oxygen. And those just happen to be the exact two components of highly efficient rocket fuel.
Ah, okay. So the regolith is brutal, sure, but the payoff is fuel.
Right. Engineers are having to develop these active electrodynamic dust shields, basically using electrical fields to repel the charged dust particles off the suits and the solar panels. But if they can solve the dust problem and prove they can manufacture fuel on the lunar surface, they eliminate the need to launch all that heavy fuel out of Earth's massive gravity well.
So the moon essentially becomes a gas station.
That's a perfect way to look at it. And the Space Reactor 1 Freedom is the engine. Traditional chemical rockets, the ones we're used to, rely on combustion. They're heavy, they're relatively slow. But nuclear thermal propulsion works entirely differently.
How so?
You use a nuclear reactor to superheat a liquid propellant, like hydrogen, turning it into a gas that expands rapidly out the nozzle. It is roughly twice as efficient as chemical propulsion. And that efficiency is what actually gives you the payload capacity to bring heavy infrastructure to Mars.
Infrastructure like those Skyfall helicopters.
Exactly.
Which is fascinating because we saw how successful the Ingenuity helicopter was a few years ago. But flying on Mars is wild. I mean, the atmosphere is roughly 1% the density of Earth's.
It's practically a vacuum compared to what we're used to.
So to generate lift, those blades have to spin at an incredibly high RPM. And sending a whole fleet implies we are moving from just basic exploration to active multi-point surveying.
We are mapping the terrain for permanent settlement. And it's important to note, it's not just the United States making these massive infrastructure leaps. Private aerospace is really providing the delivery mechanisms for global autonomy now.
We're definitely seeing that today. Rocket Lab is launching Europe's first 2 navigation satellites. They're called the Celeste satellites, and it's for the European Space Agency, the ESA. They're using their Electron rocket to launch these early today, March 25th.
And the Electron rocket is uniquely suited for this specific kind of job. It's a small-lift launch vehicle.
Meaning what, practically?
Meaning it doesn't require this massive multi-year manifest to get a payload to space. For Europe, relying on Rocket Lab means they don't have to wait for space on a giant heavy-lift rocket from SpaceX or Arianespace. They get dedicated precision orbital insertion for their own navigation network.
So it's a critical step for European technological sovereignty. They don't have to rely on anyone else's schedule.
Precisely.